Hello students, welcome to Sri Jayendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 3 of our unit Thermal Properties of Matter. So let's begin with today's class. In today's class we are going to see the thermal expansion of the liquids. So let's have a look, because in the last class we were discussing the thermal expansion of solids. Now in this case, in this class, we are going to discuss about the thermal expansion of liquids. Liquids have only volume but no definite shape of their own. So liquids have only volume expansion on heating. So it is having only this expansion. Solids can be heated directly, but liquids cannot be heated directly. Liquids are to be taken into a container and then it is going to be heated. So this is the actual problem, that when I need to heat up the solid, what I need to do is that take that rod, heat it up directly. But in the case of a liquid, this could not be the situation. It is first need to be filled up into the certain container, and then you need to heat up that container, and indirectly that heat is going to be provided to the liquid. So this would be the situation. So when a liquid in a container is heated, both the liquid as well as the container expand. So in the case of a liquid, there are two types of an expansion. One is the apparent expansion, and the second is absolute or real expansion. So let's look at this, how this apparent expansion and absolute or real expansion behaves. First, let's discuss about the apparent expansion. When a liquid is heated in a container, the observed change in volume of the liquid relative to the container is called as the apparent expansion of the liquid. So this is basically an expansion which we feel. It is not the real expansion. It is something like that whatever we observe, that kind of expansion can be considered as an apparent expansion. Now the apparent expansion of the liquid, it depends on the first, it's the nature of the liquid, next nature of the material of the container, initial volume of the liquid, and change in temperature. Let's look at the coefficient of apparent expansion of a liquid. It is basically the ratio of the apparent increase in volume of a liquid, it's a delta V, per unit rise, it's a delta T, of temperature to the original volume, it's a delta V. So this gamma apparent could be written as delta V by V into delta T. While I say delta T, it is basically the change in temperature. So this is delta V by V into delta T. It is measured in Kelvin inverse or degree Celsius inverse. So when I write this, V2 minus V1 divided by V1 into bracket T2 minus T1, V1 is the initial volume of the liquid at temperature T1 degree Celsius, while V2 is the initial volume of the liquid. V2 is the initial volume of the liquid at temperature T2 degree Celsius, and gamma apparent is known as the coefficient of apparent expansion of the liquid. Does it clear up till now? So do you understand what gamma apparent is? Even this is just the primary information. We are going to have it by a certain kind of practical situations. But is it clear up till now? Is it clear? Now let's first understand what is real or absolute expansion. So they said that when a liquid is heated in a container, the real change in the real change in volume of the liquid is called as the real or absolute expansion of the liquid. And this real or absolute expansion of the liquid, it depends on the first, depends on the nature of the liquid, it depends on the initial volume of the liquid, and it depends on the change in temperature. It depends on these three parameters only. It does not depend on what is happened to the container, because this is just the observation. This is just the observation of the real expansion of liquid only. Does not depend what is happening with container. I hope this is clear. So it's a coefficient of real or absolute expansion of a liquid. Basically, it is a ratio of real increase. It's a delta V in volume of a liquid per unit rise. It's a delta T to the original volume. It's a V. So this gamma real could be written as V2 minus V1 divided by V1 into T2 minus T1 per degree Celsius. This gamma R, this is what we call as the coefficient of real expansion, and this is to be measured. This is to be measured in Kelvin inverse or degree Celsius inverse. I hope this is clear. Is it clear? Is it clear? Are you sure? So ready for the quick questions? Let's have a look. It says the liquids have only, it is having only volume, it is not having an area. That you understand. Next, real expansion. Real expansion of a liquid depends on the nature of the liquid. Yes. It depends on the change in temperature. Yes. Size of the liquid molecules. No, it does not depend on this. So the answer or the correct answer should be both A and B. Next, when a liquid is heated in a container, the observed change of the liquid relative to the container is called as the apparent expansion of the liquid. I hope this is clear. Is it clear? Are you sure? Are you sure? Great. Now let's look at one of the practical question, and this will clear all the concepts of this liquid expansion. Let's suppose this is container, and in this container, let's suppose a liquid has been filled up to the brim, something like this, and this container is being heated up by something like this, delta theta degrees Celsius. Now the situation is, let's suppose understood that what we are supposed to do is, we understood that there is a volume expansion would be there, but we will see this and we will observe this according to the height. Yes, that will give us a certain feeling that yes, this is being increased and this is being decreased, because we can deal with the levels, that level of the liquid increases or level of the level liquid decreases, something like that. So now let's suppose understand that if let's suppose I am hitting this by the delta theta, I am hitting this by the delta theta, and the situation is of, in the first case, if gamma of a solid is greater than, if gamma of a solid is greater than the gamma of the liquid, this is the situation, that gamma of the solid is greater than gamma of the liquid, what will happen? So when I say gamma of solid is greater than gamma of liquid, the situation would be something like this, that solid will expand more as compared to the liquid will expand. At this point of time, height of a solid is h. Even liquid has been filled up to the brim. So even this is having a height h. Now, as solid is going to be expanded more, the situation would be something like this. Please try to feel this. Yes. So this is h plus x for the solid. This is h plus x for the solid. So I can say that what we feel, what is not actual, I'm not talking about. I'm talking about what we feel. We will say this liquid level is fall. Yes, it is decreasing in height, or I should say container is increasing in height. So in this situation, it's a gamma of apparent, is equals to, it's a gamma of apparent is equals to what I observe is the gamma of solid minus gamma of liquid, because here in this case gamma of solid is greater than gamma of liquid. It's a gamma of solid minus gamma of liquid. I hope this is clear. Yes, this is what we feel. Is it clear? Is it clear? Now, let's look at the second case. Let's look at the second case. In this situation, let's suppose gamma of solid is less than gamma of liquid. So the initially the situation was, this is the initial situation, liquid has been filled up to the brim. Now in this case, the if I'm going to heat up, this is the initial situation. If I'm going to heat up, and if I understood that gamma of liquid will be greater than this, gamma of liquid will be greater than this, then if if the situation will be something like this, that this liquid has been already filled up to this, but it has been overflow, something like this, because liquid has been expanded more as compared to the gamma of solids. So we can say that level of liquid rises. Yes, it's a level of liquid is rises. That means it is overflowing if it has been filled up to the brim. So that means level has been increased. That is what we understood. In this situation, the apparent expansion would be equals to gamma liquid minus of gamma solids. What you feel? I hope this is clear. Is it clear? Is it? Great. Now let's discuss the third case. Let's suppose, let's suppose that gamma of solid is equals to gamma of liquid. So this is the initial situation, that a container was there and liquid has been filled up to the brim of the container, and it was being heated up. It was being heated up, and this both, that the gamma of solid and gamma of liquid are equal. So if this are equal, the situation would be, this is the initial situation. When I see the final situation, if I understand that this has been increased by certain amount, even the liquid will be increased by certain the same amount. So if this both are being increased by the same amount, the situation would be something like this. Look at this, that it will appear like this only. So this is the final situation. This is the final situation. When this is the final situation, it means that there is there is no change in the level of liquid. There is no change in the level of the liquid. Have you got this? Yes. Do you understand this? There is no change in the level of the liquid, and in this case gamma apparent would be equals to gamma solid minus gamma of liquid, but this will be 0 because this both are the equal. But always remember one thing, that you always compare gamma of solid with gamma of liquid. You cannot compare alpha of solid with the gamma of liquid. I hope this is clear. Is it clear? Is it clear what I mean? Do you understand this? Do you understand this? Are you sure? Are you sure? So let's just summarize this. Let's just summarize this three situations. That in first case, if gamma of solid is greater than gamma of liquid, then the level of liquid will fall. In a second case, if gamma of solid is less than gamma of liquid, if gamma of solid is less than gamma of liquid, then its level of liquid will rise. And if gamma of solid is equals to gamma of liquid, then the level of liquid will appear to same. Yes, this is about the apparent expansion. So in this case, if I have been asked that find out the gamma apparent, I will write out it's a gamma s minus gamma l. In this case, gamma apparent is equals to gamma l minus gamma s, and in this case, gamma a is equals to 0 because both are equal. Have you got this? Have you got this? Do you understand this completely? Any doubts in this? Is there anything? Do you have any doubts in this? Anything? Do you have? Do you have any doubts? Are you sure? Ready for one of the question? Are you ready? Let's have a look. Suppose the question is, suppose container is there, and in this container a liquid has been filled up, and this container is being heated up. As you can see this, let's say if alpha of container is 3 into 10 to the power minus of 5 Kelvin inverse, and gamma of liquid is 5 into 10 to the power minus of 5 Kelvin inverse. Find, or I should say, what would be the situation if container is being heated up by delta theta degree Celsius. So what I need to do is I need to just check there both the gamma. The mistake we commit is this is alpha, and we are in that hurry that we don't understand that this is alpha. This is just the linear expansion of solid. But I need to compare a gamma. It's a volumetric expansion is to be compared. So gamma of a container, or I should say gamma of a solid, is equals to 3 times of alpha of the solid. So this is equals to 3 into 10 to the power minus of 5, which should be 3 3s are 9 into 10 to the power minus of 5. And this is gamma of solid, and gamma of liquid is 5 into 10 to the power minus of 5. So as I observe that gamma of solid is greater than gamma of liquid, gamma of solid is greater than gamma of liquid, and as gamma of solid is greater than gamma of liquid, level of liquid level of liquid will fall. I hope this is clear. Is it clear? Is it clear? Is it? Great. If in this question I have been asked about the gamma, it's an apparent expansion of liquid, then I will write apparent expansion of liquid, it's an apparent expansion of solid, or I should say volumetric expansion of solid minus volumetric expansion of liquid. This can be also written as 3 times of alpha s minus of alpha l. I hope this is clear. This is the apparent expansion gamma into A. Yes, this would be equals to 3 into alpha. It's a 3 into 10 to the power minus of 5 minus gamma of the liquid, it's a 5 into 10 to the power minus of 5. This is 3 3s are 9 minus 5 into 10 to the power minus of 5. This is equals to 4 into 10 to the power minus of 5 Kelvin inverse or degree Celsius inverse. You can write whatever you want. I hope this is clear. Is it clear? Is it clear? So now do you understand completely what make it different when I heat up the liquid. Are you sure? Great. So let's just wind it up the session over here. Yes, this was all about the expansion of liquid, or I should say thermal expansion of liquid. Please practice a little. This will help us to make it done quickly and clearly. Thank you. Have a good day. Take care.